Okay, so hello and welcome to this video tutorial for A-level mechanics. So we have this problem from the June 2023 paper here. The problem is all about particle P. It's moving along a smooth horizontal plane. It has this constant acceleration, which is described as a vector here. We note that at time t equals 0, the particle passes through point A. At time t equals 5, the particle passes through point B. And we also have the velocity of the particle as it passes through point A. And we're first being asked to determine the speed of the particle as it passes through point B. Okay. Um, Note that we're given the acceleration here. We're given a constant acceleration as a vector quantity. And we're being asked to determine the speed of the particle at a certain point in space / time. If you want to bridge the gap between acceleration and velocity, we can note this idea here where we say that acceleration is just the time derivative of velocity, which makes sense, right? If you want to describe acceleration to someone, you might say acceleration is the change in velocity over the change in time, which is exactly what we have here, right? So we can kind of equate this idea to dv over dt, and what we have here is a differential equation. How might you typically solve a differential equation? Well, we can use integration, right? So when I integrate dv over dt with respect to t, we will have v. So we'll have a function for the velocity of the particle with respect to time. Let's go ahead and integrate this then. We can say that v is equal to 2.4 ti plus tj. Plus our constant of integration here. Now, to solve for our constant of integration, we'll want a particular point in time. So we can take this idea here where we're given the velocity of the particle as it passes through A, also noting that time is equal to 0 when the particle passes through A. So we can say then minus 16 I minus 3j is equal to c. Since t is equal to 0 here, these two terms cancel out. We can kind of combine these two ideas to give an overall function for velocity with respect to time. We can say that velocity is equal to 2.4 t minus 16 I plus t minus 3j. So we have a function of velocity with respect to time here. We're being asked to determine the speed of the particle p as it passes through B. Let's note here that time is equal to 5 when the particle passes through point B. So we can say that v at t is equal to 5 is equal to 12 minus 16, that's minus 4, I plus 2j. Note this isn't our final answer since this is velocity and we're looking for the particle's speed. If we want the particle's speed, then we can take the magnitude of this velocity here. We can say s at t equals 5. I'm denoting speed with s here. S at t equals 5 is equal to 4 squared plus 2 squared, all rooted, which can be taken as root 20, which can be taken as 2 root 5, which can be taken as 4.47 meters per second. Meters per second. Cool. So we have part A there. Part B for this problem, it's a very similar idea to what we just dealt with in part A here. So we're now being asked, we have the position vector of A, we have the position vector of C, although it's got a little unknown in it there, this lowercase c. We, in effect, in the same way that in part A we kind of bridged from acceleration to velocity, here in part B we're effectively trying to bridge from velocity to displacement or position. Right? Again, we know that velocity is nothing but the change of displacement over a change in time, so we could describe that mathematically as v is the time derivative of displacement. So we can say then that this this idea here is equal to ds over dt. So when I integrate it with respect to time, that will give me a function of displacement with respect to time. So we can say that s is equal to 6/5 t squared. I've just added 1 to the power there and divided by the new power, minus 16t I plus a half t squared minus 3t times j plus our constant of integration here. Again, note that the position of the particle takes this 44i minus 10j when t is equal to 0, since t is equal to 0 at point A, and this is what point A is. So we can say, therefore, 44i minus 10j is equal to c, since if t is equal to 0, then all these t ideas cancel, or they turn to 0, don't they? Combining these ideas, let's write this whole thing out then, just to be complete. So we have displacement, or the displacement of the particle as a function of time here. And we note that when t is equal to capital T seconds here, that the particle passes through point C, and that the position vector of C here is 4i plus cj. So effectively substituting in our time here, our capital T, we could say that at the point in time where our particle is passing through point C, this coefficient here is equal to 4. Okay, since the kind of I coefficient at point C is 4, when lowercase t takes a value of uppercase T, this is equal to 4. I trust that that makes sense. So I can say, therefore, 4 is equal to 6/5 of capital T squared minus 16 capital T plus 44 here. Let's equate this to 0, as you typically might with a quadratic. Now, when we rearrange this, let me just check my notes here. We rearrange this, we can simplify it down to something like 3 capital T squared minus 40 t plus 100. This is quite a difficult quadratic to factorize in your head. So we might want to introduce the quadratic formula here. Let's just write it out. So we can say here our A coefficient is 3, our B coefficient is minus 40, and our C coefficient is 100. When we bung these ideas into our calculator, we have a t value of 10 and an alternative t value of 10 thirds. Note in the question it says that capital T is greater than 5, and since 10 over 3, what's that, 3 1/3, that is less than 5, we can kind of rule that one out and say that T is equal to 10 here. Looks more like 16 than 10. There we go. Okay, so that is our value for capital T. We have that now. Let's just put a unit on it just to clarify it. Okay, let's move on to part C. Find the value of C. Well, note that as the particle is passing through point C, we can say that this coefficient here equates to our lowercase c. And we have the value of time at that point, right? It's equal to 10. So we could say then that lowercase c is equal to 1/2 times 10 squared minus 3 times 10 minus 10. So that's going to be 50 minus 30 minus 10. That's equal to 10. So we can say that c is equal to 10. Okay. Awesome. So these are the answers to our problem here. If you have any questions or comments about that problem, please feel free to leave them down in the comment section down below. Otherwise, thank you very much for watching.